Good morning, students. Let us continue with Chapter 9 Force and Laws of Motion. The contents of today's session are the exercise problems from pages 128 and 129 of your NCERT textbook. Today we will do the questions from 7 to 14. Question 7. A 8000 kg engine pulls a train of 5 wagons, each of 2000 kgs, along a horizontal track. If the engine exerts a force of 40,000 Newton and the track offers a friction force of 5,000 Newton, then calculate A. the net accelerating force, B. the acceleration of the train, and C. the force of wagon 1 on wagon 2. Now here, first of all, in A, we have to calculate the net accelerating force. That means the total force acting here. Here the force exerted by the engine is 40,000 Newton and the opposing force of friction offered by the track is 5,000 Newton. That means here two forces are there. We need to find the total force acting here. So the net accelerating force F is given by force of engine minus force of friction. The reason why we take minus instead of plus here is the force of friction exerted by the track is opposite in direction to the force of engine. That is why instead of plus we use minus here. So that equals 40,000 minus 5,000, that is equal to 35,000 newtons. Thus, the net accelerating force F exerted by the engine is 35,000 newtons. This force will be used in further calculations now. In B, next we need to calculate the acceleration of train. Just now we found out the value of net force as 35,000 Newton. Now we need to find the acceleration of the train. We know that the formula F equal to m into A. That means A equals F by m. So here we found the net force. We need to know the mass of the entire train. In the question, the mass of one wagon is given as 2000 kg, but the train consists of 5 wagons. That means the mass of the train will be 10,000 kgs. So now we substitute this in force equal to m into A formula. So 35,000 equal to 10,000 into A. Therefore, A equals 35,000 by 10,000 meters per second square. So we get the acceleration A equal to 3.5 meter per second square. And this is the acceleration of the train. Next, C part. Here we need to calculate force exerted by wagon 1 on wagon 2. Now in the picture, if we look at the entire train, there are total 5 wagons behind the engine. Now the question is telling what is the force exerted by wagon 1 on wagon 2. That means here we need not consider wagon 1 when we consider the mass. So here we need to find the mass of 4 wagons instead of 5 wagons. Force of wagon 1 on wagon 2 will be equal to mass of 4 wagons into acceleration. Here the reason we took 4 wagons are there are total 4 wagons behind the wagon 1. That is why we have taken 4 here. This equals 2000 into 4 into 3.5, where 2000 is the mass of 1 wagon and 4 is the number of wagons and 3.5 is the acceleration we found out just now. This equals 28,000 Newton. Thus, the force exerted by wagon 1 on wagon 2 is 28,000 newtons. Question 8. An automobile vehicle has a mass of 1500 kgs. What must be the force between the vehicle and the road if the vehicle is to be stopped with a negative acceleration of 1.7 meter per second square? Given here are the mass of the vehicle m equal to 1500 kgs and acceleration a equal to minus 1.7 meter per second square. Here minus sign indicates it's a negative acceleration. We use the formula for force F equal to m into a. Substituting the values of m and a, we get F equal to 1500 into minus 1.7 newtons. Finally, F equal to minus 2550 newtons. Here, the minus sign indicates that the force acts in a direction opposite to the direction of motion of the vehicle. Question 9. What is the momentum of an object of mass m moving with a velocity v? The options given are A. mv whole square, B. m into v square, C. half mv square, D. mv. We know the momentum of an object is defined as the product of mass and velocity. Therefore, the answer will be D, that is m into v. Question 10. Using a horizontal force of 200 newtons, we intend to move a wooden cabinet across a floor at constant velocity. What is the frictional force that will be exerted on the cabinet? First of all, let us understand that a wooden cabinet, that means a wooden shelf, is moved across the floor by applying a force of 200 newtons and the cabinet is moving at constant velocity. Here there is one more force, that is frictional force. This force exists between the floor and the cabinet, and this force is exerted by the floor on the cabinet. Now if we observe the term constant velocity, that means here there is no change in acceleration. In such a situation, the frictional force will be equal to the applied force. So the answer here is 200 newtons. Question 11. Two objects each of mass 1.5 kg are moving in the same straight line but in opposite directions. The velocity of each object is 2.5 meter per second before the collision, during which they stick together. What will be the velocity of the combined objects after collision? Here we have two objects having the same mass 1.5 kgs each. They are moving with the same velocities with the value 2.5 meter per second. But we consider the velocity of the second object as negative because it moves in the opposite direction to that of the first one. Here the question is asking us to find out the velocity of the combined objects after the collision. So in the first part, we will first of all calculate the momentum of the first object. We use the formula m into v. So since it's the first object, m1 into v1. Substituting m1 as 1.5, v1 as 2.5, we get 3.75 kg meter per second. Now we will calculate the momentum of second object, that is m2 into v2. Substituting m2 as 1.5 and v2 as minus 2.5. Remember, here the minus sign is the opposite direction to the first one. That equals minus 3.75 kg meter per second. Now the total momentum equal to 3.75 plus in the brackets minus 3.75. This is the momentum before collision. So we get the answer as 0 kg meter per second. Next, we find the total mass of combined objects, that is m1 plus m2, that equals 1.5 kg plus 1.5 kg equal to 3 kgs. Now let the velocity of combined objects after collision be v meters per second. Now this is the value we have to find out finally. So the total momentum is given by total mass into the combined velocity. That equals m1 plus m2 in the brackets into v. This is the case after collision. We know m1 plus m2 is 3 kg. So substituting 3 kg into v, we get the total momentum after collision. According to the principle of conservation of momentum, the total momentum before collision equals the total momentum after collision. So, before collision we got the total momentum as 0 and after collision we get it as 3 into v. Substituting these values, we find v equal to 0 divided by 3. Therefore, v is 0 meters per second. Thus, the velocity of the combined objects after the collision will be 0 meters per second, which means that the combined objects will come to a stop after the collision. Question 12. According to the third law of motion, when we push on an object, the object pushes back on us with an equal and opposite force. If the object is a massive truck parked along the roadside, it will probably not move. A student justifies this by answering that the two opposite and equal forces cancel each other. Comment on this logic and explain why the truck does not move. Now here the focus is on the object, that is a heavy truck parked on the roadside. Now the heavy truck is not moving. As per the student, the logic explained is when we push the truck also exerts an equal and opposite force on us. That is why the truck is unable to move. But the logic of the student is wrong because this is impossible, as according to third law, the action and reaction forces do not act on the same body but on different bodies. Now the reason why the truck doesn't move here is when we try to push the truck, that force is very small compared to the force between the wheels of the truck and the road. That force is frictional force. So as long as the force with which we apply or push the truck is smaller than the frictional force, the truck will not move. Question 13. A hockey ball of mass 200 grams traveling at 10 meters per second is struck by a hockey stick so as to return it along its original path with a velocity of 5 meters per second. Calculate the change of momentum occurred in the motion of the hockey ball by the force applied by the hockey stick. Here, first of all, we will calculate the initial momentum. For this, the mass of the hockey ball given m1 equal to 200 grams. We convert this mass into kg by dividing by 1000. So the mass we get as 0.2 kgs. And the initial velocity given here is v1 equal to 10 meters per second. So the initial momentum is found by using the formula m into v, that is m1 into v1. That equals 0.2 into 10, that is equal to 2 kg meter per second. Next we calculate the final momentum. For this, we take the mass of hockey ball again. M2 equal to 200 grams. That converted into kg, we get 0.2 kgs. And the final velocity V2 is given as minus 5 meter per second. Here, if you notice, we use the sign minus because the hockey ball, which was moving in the forward direction, once it is struck by the hockey stick, starts moving back. That is why here minus sign is considered. The final momentum is found by the formula m into v, that equals m2 into v2. Substituting the values, we have 0.2 into minus 5, that equal to minus 1 kg meter per second. Now to find the change in momentum. That is given by final momentum minus initial momentum. We got the final momentum as minus 1 and the initial momentum was 2. So, taking these values, we get minus 3 kg meter per second. Therefore, the change in momentum of the hockey ball is 3 kg meter per second. Question 14. A bullet of mass 10 grams traveling horizontally with a velocity of 150 meter per second strikes a stationary wooden block and comes to rest in 0.03 seconds. Calculate the distance of penetration of the bullet into the block. Also, calculate the magnitude of the force exerted by the wooden block on the bullet. Now here in this problem, we need to find two things. About a bullet that is fired with a velocity and it strikes the wooden block and comes to rest. So the two things we have to find out are how much distance the bullet will go inside the block. And the second one is what is the value or magnitude of the force exerted by the block on the bullet. Now in the first part, we will calculate the acceleration or rather retardation of the bullet. For this, given here are initial velocity u equal to 150 meter per second, final velocity v equal to 0, and the time t is given as 0.03 seconds. Substituting the values of u, v and t in the formula v equal to u plus at, we get 0 equal to 150 plus a into 0.03. From this, we find the value of a as minus 5000 meter per second square. Here, the minus sign shows that the acceleration is a negative one or retardation. From this, let us calculate the distance of penetration of bullet. For this, we use the formula v square equal to u square plus 2as. Substituting the values of v as 0, u as 150 and a as minus 5000, we get 0 equal to 22,500 minus 10,000 into s. Therefore, s value is found to be 2.25 meters. This is the distance of penetration of the bullet into the block of wood. Next, we will calculate the magnitude of force. For this, we use the formula force equal to mass into acceleration. Force equal to mass 10 kg, but here the mass given is 10 grams. So we convert it into kg as 10 divided by 1000 kg into acceleration minus 5000 meter per second square. So the value of F equal to 50 newtons. Students, if you notice here, actually the answer is negative, minus 50 newton. But here we are not showing the negative sign because the question they are asking to find the magnitude of the force. That is why we need not show minus sign here. That's all for today, students. Thank you.